So here we go, complex fractions. Oh, cool. That's a nice little design there. So a complex fraction is a fraction that looks like this. Ooh, that didn't work. How about this? It basically looks like two fractions stacked on top of each other. One rule here. Only one of those letters can actually be 0 to be correct. Which one could it be? B. Only A can be 0. None of those other ones can be 0. Otherwise, it would be what? What do we call it? What do we call it if any of those?
Undefined.
Undefined, right? If they're both 0, they're indeterminate. All right? Our goal when we have a complex fraction is to eliminate this denominator. And guess how we do that? How do we get that denominator to turn into 1? We do the reciprocal. That means we're going to multiply the bottom by d over c and the top by d over c. That turns the bottom into a 1, which means I don't have to write that down anymore. And then the top, I have to multiply. So that's going to be AD over BC. That's not too hard, is it? All I have to do is multiply by the reciprocal. That eliminates the work for me because all you're doing is changing the denominator to a 1 by our reciprocal rule. That helps us out a lot. After that, all it takes is a little bit of thought. B and C can't be 0. So how do I get rid of that C? So what's the reciprocal of C?
1 over C.
1 over C. That's key because not everyone gets that, so very good. Okay, that changes my denominator to a 1, so I don't have to write it down anymore. And that takes the top to A over BC. I'm glad you caught on to that, Beck, because it gets confusing if you don't. C and B can't be 0. So what do I do? Someone tell me.
Flip it so it's U over 1.
Yep. Same thing, top and bottom. To do to one side, you have to do to the other. It's always the rule. What do you get?
B over C.
B over C. What do you think? That's not hard, is it? Or is it? Okay. What about this one? Couple things. X can't be 0, B can't be 0, A plus X can't be 0.
So would you do A plus X over B?
Yep. On both sides. It's still going to do the reciprocal. The only trick to this one, those become 1. The only trick to this one is how do you write your answer?
Distribute.
Yes. And I would just do it like
Squared
this.
X squared plus.
I won't even distribute it. I'll just write it out just like that. You could do a squared plus ax. You could totally do that. Nothing wrong with that. But you don't need to. All right? Pretty good? All right. So this is one of the things that we can use to justify what we're doing. This is called the, funny word, funny term, the denominator-numerator same quantity rule. Okay? Denominator, numerator, same quantity rule. All right? Which means if I multiply by the reciprocal, I get 1, right? All right, so it's one of those standard things that we will do. Any questions on these? Think they're hard? Let's do one more. Someone, you don't have to come up here unless you want to. Someone come up and tell me what you think this answer is. This one looks different than all the other ones we've done. You could tell me, or
Or then you put, like W plus C over 1.
okay, so I could write it like this.
Yeah, and then you put 1 over W plus C.
Yep.
You do W times W plus C. Like W.
Okay, so what do you get?
Oh, there's another one.
I added that. Just for simplification. So you get W over W plus C, right? So any questions?
What if the
Oh, it's a one.
addition, like, variable thing is at the top?
What if it's at the top?
Yeah, so
It would be
like,
1 over W plus C.
no, like W plus C over W over 1. Like, if that,
If it was like this,
yeah, yeah,
like that,
yeah,
You do that.
there'd be 1 over W, 1 over W. Okay? What if it's like this? Let's change it up. What if it's like this?
Then W plus C over 1. Oh my goodness. Oh yeah, it's W plus C over 1 times 1 over W plus C.
So this is W over 1, right?
Yeah.
Okay. So then you get,
Yeah.
then you get that, right? So you kind of have to pay attention to where your fractions are. Okay? Because this one looked different than these. Right? So make sure you're careful when you're thinking about those as well. Any questions? Cool. You're ready to rock and roll?